Good afternoon, everyone, and welcome to the final session of our webinar series on heat pumps. The session is brought to you by Northwest Net Zero Hub and Stiebel Eltron. My name is Namita, and I'm a Net Zero Project Officer at the Northwest Net Zero Hub. Joining us today, we have Shaun, who is the International Trainer at Stiebel Eltron, and will be delivering today's session on maintenance and repair. We also have Marissa, the Hub Home Energy Lead, who will be guiding the Q&A section of the webinar. Over the past few months, we have hosted a comprehensive series of webinars covering heat pump systems, planning and specification, and commercial heat pump solutions. If you have missed any previous sessions or would like to revisit a topic, all webinars have been recorded. We'll share the links with you after today's session, and the recording are also available on our website. To further advance the learning from the webinar series, we will be having an in-person session at Stiebel Eltron's Bromborough site. I'll be sharing further details with all participants after today's session. As mentioned in the earlier webinars, the Northwest Net Zero Hub is funded by Department of Energy Security and Net Zero, and is part of a network of regional hubs across the country. We are hosted by the Liverpool City Region Combined Authority, and our role is to provide free technical support to public sector organizations on their decarbonisation journey. This webinar series is one of the ways we support public sector organizations across the region and beyond. So without further ado, I'll hand over to Shaun, who will take us through today's session on maintenance and repair.
Thank you. Hi everyone, thanks for joining us. Just going to quickly load up my presentation and we'll begin looking at the service and repair. If you do have any questions, if you'd like to pop them in the chat, and we'll have a Q&A session towards the end. I will just get right into it and for the next 30 minutes or so talking about service and repair maintenance. Okay, so just to quickly go over the agenda of what we'll be looking at. So we're going to talk about why service and repair matters, heat pump systems as a whole and not just as a single appliance, what is in a typical heat pump system and its components, what servicing involves in practice, so what you'll actually do if you go to site, common issues and how they're prevented, and then we'll do a quick key takeaway and summary. Okay, so first of all, we're just going to quickly look at why servicing matters for heat pumps, and it's actually quite important, servicing for heat pumps. Heat pumps that are serviced and maintained correctly, it means that they perform as they're intended to. It makes them more reliable, and it keeps the running costs down as well. Heat pumps that aren't performing as intended typically can have high running costs and suffer with performance. So when we're thinking about them as well, just remember it's not just the heat pump itself. We've got to look at the whole system, and the whole system is composed of controls, electrics, refrigeration circuit, heat pump, hydraulics, all those sort of things is what we're going to be looking at. So if we take a look at a sort of typical heat pump system, I hope you can all see my screen okay. We'll just have a quick look at this. So heat pump system is not just an appliance. So here you can see we've got a domestic hot water tank, buffer cylinder, expansion vessel, and there's a lot of pipe work and things like that. All of these things have to work together to make the heat pump run effectively. With heat pumps, they typically don't fail in spectacular ways. What they generally do is they sort of drift in sort of performance over time. And that's where the service and maintenance sort of side of things comes in when we're looking at that. So what we're actually looking at when we go and do a service or a maintenance call, we are looking at how small faults can lead to big efficiency losses. We will cover some of the faults as well. Reliability, safety, and warranty. So the reliability of the machine is dependent on a lot of factors. So, like I say, controls, hydraulics, sensors, and things like this. And in terms of safety, we have the expansion vessel. If anyone is G3 qualified, this is a government regulation that you have to be qualified to install these expansion vessels. So it is a safety requirement which needs to be checked annually. And most failures are avoidable with heat pumps if proper service and maintenance is carried out. Okay. Some of the common issues you might see are people might complain of a noisy unit or higher energy bills, low output of the machine, and with it relying on sort of airflow as well. If it's an air source heat pump, you can get flow restrictions and things like that with the air source heat pump. Okay, so just going to quickly talk through this. Then this is a typical heat pump system that you would see, and the components that you might come across, or you probably would come across in any typical heat pump installation. So here we've got a domestic hot water tank. I'm not. Can you see my mouse where I'm hovering? I'm not sure here. So storage tank here. This is for our domestic hot water, so our potable water for the property. Up on the wall here, we have the heat pump manager. The heat pump manager's job is to tell the heat pump when to run, tell the components what they need to be doing at any given time, and to monitor any sensors and flow rates and refrigeration pressure of the heat pump itself. Can't really see it, but the heat pump is housed just outside the window. So that's actually the part that's outside. Expansion vessel, which is just down here. Generally, you will have two of these. You'll have one for the domestic hot water, and you'll have one for the heating side of the system. You'll have circulation pumps, which are just here. And then you'll have filters and strainers, some form of electrical isolation, and automatic air vents, which are just here. So on a typical install, these are the components that you would need to check. They can vary from system to system, but as a baseline, generally these are components that you would see in most heat pump systems. So you don't necessarily need to know how to fix those, just know that they need to be checked and addressed when you're doing a service and maintenance call. Okay. So I'm just going to quickly move on to this next slide. So in reality, when we're looking at servicing, what it means for you if you go to site in reality, it's basically a routine health check for the heat pump to make sure that it's running as it's intended. So it's not a full recommissioning of the system. It's checking that the current parameters still match the initial commissioning parameters. As I'm sure you all know, people change things over time. So we just need to check that the parameters that are set are the same as the original commissioning parameters, right? And it should focus more on performance, safety, and reliability. So we're not actually looking for faults per se. What we're looking for is anything that could cause a decline in the performance of the machine. So things that affect the performance of the machine might be flow rate. You could have blocked evaporators, this sort of thing. So quickly just go to what most service actions are on a typical day if you were to go. So most of them are just a visual check of the system. So you're visually checking the system to make sure that there's no corrosion of any components, any leaks, any sort of damage to any of the system components, and cleaning the air source heat pump if it's an air source heat pump. So with an air source heat pump, actually, the machine outside doesn't need a lot of taking care of. It's the actual system inside that needs most of the attention. If we were to service an air source heat pump, you would clean the evaporator of any, debris, make sure the condensate drain is clear of any leaves so that the water can run off in defrost cycles. And then you may give it a visual inspection to make sure there's no leaks internally to the machine. But other than that, most of the servicing will be done on the system side of things. And when I say system side, I'm talking about inside the property, to do with pumps, filters, all those sort of components. Okay. So basically what servicing is doing is identifying any potential issues that would later become faults if they weren't addressed. Okay. Um, okay. So I say when we're looking at visual inspection, so quick example here. If we were doing a visual inspection of this typical install here, the first thing we'd be looking for is, do we have minimum clearances for the machine? Is it accessible and allow you to do the work? So in this example, we can see we've got, uh, there's clearly enough room at the back for us to do a visual check of the evaporator fan. There's plenty of space underneath, so we can check if the condensate's clear. We can see if there's any visible signs of damage or corrosion. And there's no, we can check for any obvious leaks and, signs of staining or anything like that might be causing issues. Okay. Just a few things that you might notice. So over time, if the evaporator, for example, was to get blocked, what that means is we can't then collect enough energy for the air source heat pump to run efficiently. So if that gets blocked over time, the performance of the machine will decline. It will still work and it will still run because they are quite robust themselves. It just means that the whole system is not operating to its maximum efficiency. So it's important in servicing that we're trying to optimize for efficiency rather than actually repair the machine. Repairs and faults come separately to service and maintenance. Okay. And most of the issues that you will see, most issues that you will come across, they're quite evident. You'll be able to see them without having to go too deep into any controllers or commissioning settings. If something's not right, normally you will see it first. Okay. One of the big important things when it comes to servicing the heat pump and heat pumps in general is water quality. And water quality is massively important for an air source heat pump or any heat pump. Water quality um, protects the heat exchanger of the heat pump. If water quality is poor, we can get the heat exchanger can get blocked up. If the heat exchanger gets blocked up, that can cause performance issues with the machine. Um, if we have blocked filters, blocked strainers, if we have a diverter valve, for example, that should move in different positions, they can get blocked. And poor water quality can cause all these issues. Okay. Um, so on a regular service, what you should do is check the water quality to make sure it is within the standard range of the heat pump that you're installing. Generally, most manufacturers will give you guidance on what the specific water quality should be and the conductivity levels of the water. So, water quality. So, what else are we looking for when we're looking at water quality? Once we're satisfied water quality is up to standard, there's a few other things that we should check when we're on site that could potentially cause issues. So, expansion vessel charge. So, just up here, you can see there's an expansion vessel. Uh, the job of this is to maintain system pressure and make sure that it doesn't get too high in pressure. So as we're heating up the water will expand, and the expansion vessel's job is to take up that expansion. If it was to get too high, generally over 3 bar, it would discharge the water in the system and keep the system under low pressure. Okay. These need to be checked on an annual service. They hold a specific charge, and usually written on the side of them, it will tell you what the charge should be. The next thing would be the actual system pressure itself. So similar to a gas boiler that you would have, you still have system pressure, usually around 1.5 bar, for example. Operates in the same way. You have a little pressure gauge here. You would make sure that's up to pressure. Circulation. So the heat pump manager will tell you what the flow rate is of the system. And depending on the size of the heat pump, they all require different flow rates, okay, to make them perform well. So circulation, we can check that in the controller. We can check our flow rates and make sure that it's within the intended values. As I say, depending on the size of the heat pump, they can vary. so you need to check those as well. If flow rate, if system pressure, expansion vessels, or flow rate, if none of those things are working, the heat pump will generally run, and again, it will run inefficiently, should I say. So if you have low pressure on the heating side of the system, so this is checking this gauge here. If this was to drop from the normal operating from say 1.5 bar to 0.5 bar, the system pressure would drop, which would decrease the flow rate of the system, which means the heat pump can't effectively transfer the heat at the speed it would like to. And then that would cause issues inside the heat pump, even though it's not the heat pump that is actually at fault. Okay. So, like I say, the heat pump will still run with poor flow, but it will just run badly. Is the key takeaway from that water quality checks. Okay. So filters, we look at filters, strainer, and air. Okay, so two of the biggest causes. Generally, these happen during commissioning, but they can happen over the summer months. So, are dirt and trapped air within the system. So, trapped air generally will get caused during the summer months when no one's had their heating on and the system has been sat idle for 3 or 4 months, and that it hasn't run any water through the system. Generally, what will happen is the system pressure will reduce over those couple of months. The water will be sat stagnant and not flowing. And then what happens then is you get air in the system as well. So that can cause issues as well. So generally, I would recommend if we're doing servicing, we want to service it before the heating season starts, not when the heating season's already begun. And then we recognize issues, and then we have to then go out during the heating season. The best time to do it is during the summer months to make sure it's ready for when the heating season actually arrives. Okay. So most heat pump problems, they don't start initially as faults. What they are generally caused by is say dirt or air or system quality. So, for example, you may have a diverter valve, just as a real world example. The diverter valve's job is to either send the heat and water to either the hot water tank or to the buffer tank. If over time we have debris building up in the system, this diverter valve can get blocked. If this then blocks, the water is not going where it's intended to, and then the machine can go into fault because it's combating that in the system. Okay. And a typical result of that would be the heat pump will keep running anyway. It would probably get louder because it has to work harder to overcome the restrictions in the system, and it would be less efficient again. Okay. So it's like trying to breathe through a blocked mask. If you had, a COVID mask on and you're trying to breathe through it and it was all blocked, that's basically what the heat pump will be trying to do. You could still breathe a little bit, but maybe, not as effectively. Okay. And all these things, they'll generally lead to loss of comfort and complaints before they'll lead to an actual breakdown. Most of the things with the heat pump doesn't typically is never the first thing to break. 95% of the issues are caused on the system side of it. Okay. And if we don't check these filters and strainers and diverter valves and things like that, the issues will just keep reoccurring. So it's important that we check those all of the time. Okay. So one of the other the important things is the controller itself. So like I said, the whole heat pump operates as a whole system. So we have hydraulics, then we have the electrical side, and then we have the control side of things. If the controls aren't set up correctly, this can cause a lot of issues as well. So the controller's job is to tell the heat pump when to actually run. The heat pump is heavily reliant on sensors and measurements from those sensors. And what can happen with sensors over time is they might get pulled out of pockets, or cables can be damaged. As a real world example, if it's in a the cylinder is in someone's garage with the sensor in the pocket, and then they go in and start moving boxes around. They may pull a sensor out or dislodge it from where it's supposed to be. Then the heat pump can't react as it's meant to because the sensors aren't positioned where they need to be. Controller settings, again, is important. So during initial commissioning, it will be set up to run as efficiently as it can be. But over time, you'll find end users will alter those settings if there's a change of property owner and they like it a bit warmer than the previous owner, or vice versa. They might come in and try and adjust some settings, and they might not adjust all of the settings correctly. So it's important that you take your original commissioning documents with you when you go to site and check that the parameters that are in there match the original commissioning and the original design of how it was intended to be used. So the effects of the heat pump controller being set incorrectly is that the heat pump might run it might run at the wrong time. It might run during the night time when it's not really supposed to. You can have reduced output from the machine if they've turned it too low. It might not be outputting correctly. But also your energy use can increase. If someone turns up domestic hot water to 55, 60 degrees, and it's doing that every day, that's going to increase energy costs massively compared to when you would normally have it at, say, 48 degrees, for example. It's important as well that we check, say, the sensor placements. So our weather compensation sensor, which sits outside on the wall, if that is in the incorrect place, or it's moved, or it's fell down, or there's water ingress into the sensor, it could potentially trick the heat pump into thinking it's maybe warmer than it is or colder than it is outside. And if that happens, it means the machine is trying to compensate for that by either running to higher temperatures or running at really low temperatures, thinking it's a lot warmer outside than it actually is. So these are the things you would see on your visual checks if you were checking the outdoor weather sensor. Make sure it's not, it's got no water ingress. It's not been put next to an extractor fan, for example. If you put it next to an extractor fan, it would come out and that warm air from the house would trick it to think it's warmer. And then you would have issues with the heat pump not be able to react and things like that. Okay. So it's more about checking that the system understands what is happening within the building and what's actually happening outside rather than actually looking at all the different settings and parameters. We just want to know that the controller understands what's happening outside and what is happening inside the building. And you can do that relatively easy with inside the heat pump manager. We can also remotely monitor heat pumps as well. So in this image you see, there's this little box here is what's called an internet service gateway. So this internet service gateway allows you to monitor the performance of the heat pump over its lifetime. And with that, you can then review the performance of the heat pump and compare data from the previous months. And it can sort of give you a timeline and you can see the degradation in the performance over time if you need to. And then what you can do is proactively go and rectify these faults or these performance issues before they even occur or before, the homeowner even knows about it. Okay. So some common problems that you will come across is generally poor heating and hot water, high electrical use, unusual noise where the heat pump is running really loudly trying to overcompensate for something, and repeated call outs are some of the common problems that you will hear. So the most common thing you will hear is you will get people saying that the system's running, but they're not warm. I say bills are higher expected, and it's not necessarily the heat pump's not broken. It's just not a comfortable temperature. And when we miss out servicing, these problems just keep reoccurring repeatedly. So an example of poor heating and hot water quality, that could be if we have, say, a diverter valve is causing an issue. We have blocked filters and blocked strainers. The system pressure was dropped because no one's topped up for a little while. water in the system's not been treated correctly and it's causing corrosion. Generally, you'll hear about an issue when these things haven't been checked. Okay, so a lot of the problems that you'll see will largely they go unnoticed for a long period of time if it's not serviced and maintained. So the reason being is heat pump systems will continue to run even as the performance declines with the system because um, they are quite robust. So they will run even if the system is not performing to its maximum efficiency. Um, and they very rarely just stop running, and they're quite tolerant. So you will quite often you won't see immediate fault codes on the system. What you're more likely to get is from tenants or the homeowner, is that they'll say that the hot water's not quite getting hot enough anymore, or the heating system's not as hot as it used to be. Um, these are the sort of things that you will get, but all of those things generally come back to the system side of things, system settings, uh, the sensor placements, um, water quality, and things like that, and the performance will drop gradually over time. But if we service it every year, that no longer becomes an issue. Um, I say most of the issues will show up as complaints rather than an actual breakdown of the heat pump itself. It's very rare that the components in the machine will fail. Um, okay. And if you think of it, it's like when it's trying to run the heat pump, it's like it's like driving your car with your handbrake sort of slightly on. It will get you where you need to go, but it probably won't be as efficient and it won't get you there as, effectively, if you like. Okay. Uh, so the next thing we look at is service issue versus faults. So faults and servicing are two separate um, issues, really. So not every fault that the machine has necessarily needs a repair or a replacement component. They just need they just needs attention, for example. So if we were looking at the expansion vessel and the system pressure, if our system pressure drops to 0.5 bar, we don't need to replace any components. We just need to top it up with some water and some inhibitor, and that takes us back to normal system pressure. Um, and that problem has been resolved then. So we have to define sort of when we have a fault with the system, if it's components or if it's a service issue. Um, so usually on a service, the main things you're going to be looking at will be air, dirt, pressure, and settings. They're the main four things, and that the system is actually still running. Um, on a typical service to make sure the machine is running as it's intended. Typically, what you would do is you would set your hot water to the maximum of 60 degrees, let's say, and you would let the machine run and make sure it can achieve its maximum target temperature. You would then set it into heating mode, and you would set it to the maximum again to make sure that it can achieve the maximum that it needs to. When we do that, what we're doing is we're making sure that if the machine ever needs to run to these temperatures, that the capability is there for it to do so. Okay. Um, with failed components, generally that means the system can't operate at all. And you'll typically know about that long before you have to go for a service. If it's a failed component, it would generally just be, it'd be a call out and be an emergency because the machine actually wouldn't be working at all. But what we do is when we do servicing, we protect all of these components from future failing. Like I say, if we have pumps, expansion vessels, when we're checking all these regularly, we avoid future failures with these components. Okay. Um, Another point here, service issue. So service being out of spec. Again, that comes back to the control logic. Or it's the heat pump is being used in a way that it's not been intended to. So some systems might have they have gas boilers or they have secondary heat sources like immersion heaters and things like that. What can happen is if the system's not performing well, it can divert to these second heat sources for assistance. If these components are regularly coming on, then it means there could be an issue with the system side of the heat pump, which again leads to higher energy costs because you're using a secondary heat source and things like that. So it's always important that we check that how the system is meant to run versus how it's actually running in reality. Okay. So when we're looking at service, what a good service prevents is unexpected breakdowns of the machine, especially during the winter months when it can be very busy. During the winter months, air source heat pumps in particular are prone to we call it's a defrost error, basically. All the machines are designed to take care of themselves. So if the evaporator on the back of the heat pump where we're collecting the energy from gets too cold, the machine is designed to pull heat from inside the property and it sends it into the heat pump and it defrosts the machine. If there's not enough energy available in the property or in our buffer tanks, or um, there's not enough flow or temperature and things like that, that can cause us to have defrost issues. So as an example, if we have a buffer tank inside the property, so this here is a combined cylinder buffer. Our buffer tank here would store maybe 20, 30 degrees of water. We'd pull the water from here, send it outside to the air source heat pump. It warms the evaporator up and it stops it from freezing up. Now, if one of our diverter valves failed, here, for example, what we would end up doing, rather than pulling the heat out of the buffer, we would then pull it out of the hot water tank, and then it would go to the heat pump. So then our hot water tank then gets cold. So then the heat pump has to then kick in and recover that energy. But then once it's doing that in the winter, we then have to defrost it again. So we pull the tank temperature back down, and then you get stuck in a cycle of pulling the energy from the wrong places. So when we do the servicing, it's important that we check all the components are doing what they're intended to do, and they're going the heat and the energy is going where it's intended as well. Okay. So it also avoids repeated fallouts. So repeated complaints of, my hot water's not getting to temperature, my heating system it's too cold. They're the real world complaints that you might get. And high running costs is typically one that you will mainly come across. They don't always point to the actual root cause of the problem, but this is what people will say is they will say the energy bills are high, hot water's not getting hot enough, the heating system's not hot enough. So they're not necessarily telling you what the problem is. You're just looking at sort of the surface of it, of what they're seeing. Okay. Okay. And like I say, so system that is looked after, it becomes very predictable and very easy to maintain if we know how it should run and what we expect it to run like. They become very predictable heat pumps. And then once they're predictable, they don't really cause any problems. So few just the key takeaways from the service and the maintenance side of things. Heat pumps do need routine servicing. Generally, you will do an annual service on an air source heat pump or a ground source heat pump, depending on what type you're doing. Annual services, as I say, usually you would probably want to do it in the summer months in preparation for the winter or when the colder periods. Most issues are system related and not actually the heat pump itself. Quite often you'll get my heat pump's not working. The heat pump relies on all those other system components to make it work. And if they fail, then the heat pump can't run. Okay. Most of the problems are preventable. So most problems with heat pumps, again, they're preventable by making sure we clean our filters. There's no air in the system. Our diverter valves are working correctly. We've got system pressure. But expansion vessels are charged correctly. And then all of these early checks, they prevent complaints and costs for the homeowner. If we do all those things early enough, we shouldn't then run into further problems down the line. And heat pumps work best when they're looked after. They need to be taken care of. I say typical service maybe take probably 3 hours if done correctly. as a sort of ballpark if you do it all and go through the system checklists for them. Okay. So that's the end from me. So should we move on to some questions?
Yeah, thanks, Shaun. Yeah, we've had a few questions come through as you've been talking. Yeah, I'll start from in sequential order. So we might have to go back to some of the earlier parts that you were discussing. But the first one came through around when you were talking about water quality. Wondering from Patrick, are issues related to failed water checks liable to damage the heat pump itself, or is it just inefficiencies that you have to be concerned by?
Uh, no, yeah. So poor water quality can damage the heat pump itself. Mainly if you get corrosion within the system. What that ends up happening is the heat exchanger inside of the heat pump itself. Basically, that is the smallest point of restriction within the whole system because it's the pipework in there is so small. So if you do have any debris or build-up, it generally, if it gets past the filters that you've got on the system, it will end up inside the heat exchanger of the machine. Um, Generally, you can flush them out to try and clean them, but most of the time you can't get all of the debris out, and then it reduces the heat exchange. Uh, yeah, reduces the heat exchange, and then your system performance drops basically. So it wouldn't necessarily break the machine, but it would lower the efficiency for sure.
Thanks, Shaun. And then, yeah, I think you've answered the second question about how many times should the air source heat pump be serviced. Yeah, one of the slides said regular, but you've spoken about an annual service before summer as being sufficient. Is that?
Yeah. It can be done anytime during the year, just annually should be done once a year. I just find in the summer months in preparation for the winter is the best time. A lot of people who service them they might get them serviced in maybe October, November. But by that time, any faults or problems, they've already happened, and then they lose a bit of comfort for maybe a couple of days while it's being repaired. So it's not as big an impact in the summer when it's nice and warm if the heating's not working. So it's better to do it preemptively rather than you know, after the fact. Yeah.
Okay, thanks. A question from Jamie. Given the limited expertise in the current market, do heat pump maintenance checks cost more versus gas?
Mm, it's difficult to put a price on maintenance of what it would typically cost. Most installers would set their own price bracket for what they would do. I've seen prices range from typically maybe 300 to £600-700 annually, depends on the size of the system. It could be a small domestic property with an air source heat pump and one cylinder, or it could be a big you know ground source installation with multiple heat pumps and multiple cylinders. Huge commercial property. So it's difficult to put a price on it, I'm afraid, compared to a typical gas install.
Thanks. A little bit more on the cost is on average, do heat pump systems have fewer maintenance issues and costs versus gas boiler over a lifetime?
Um, if they're serviced correctly, they shouldn't require any more than the standard you would do on your gas boiler annually. So you have your annual gas boiler, it's checked. If you were doing an air source heat pump, if you're doing it annually and servicing it every year, typically you would do it once a year and it should run fine over its lifetime, as long as the servicing and maintenance is done correctly. Um, so yeah, it's similar. I would say you do it annually, maintain it correctly, and you shouldn't have any problems that you would normally have.
Great, thank you. When you were talking about, oh, I've forgotten the slide now, I'll ask the question. Where are and what defrost valves do?
Oh, is it when we were referring to the defrost cycle?
Yeah, I think so,
Um,
yeah.
okay. So yeah, a defrost valve basically is inside the machine. It's part of the refrigeration circuit, and basically what we do is normally we collect energy over the evaporator on the back of the machine. So we pull warm air over the evaporator, and we take that warm air and then we put it into the property. Defrost valve, basically, it reverses that cycle and it switches over and it reverses the refrigeration system. So instead of taking warm air from outside, we take heat from inside the property or the buffer tank, and we use that for the refrigeration process. Then we send heat into the evaporator. It just reverses it, basically. It's what allows us to do heating and cooling with an air source heat pump. That's the effect of the defrost valve.
Okay, thank you. We had another question on costs, but you've answered that, rough estimates of annual service costs. So Thomas, I wonder if you wanted to, I'm just reading your question now. I'll read it out, and if there's anything else needed, please feel free to jump in. Could an incorrectly installed RCD cause issues with the heat pump unit, such as fitting a type over a type B?
Yes, they can. So depending on the installation or what heat pump you have, typically you would use a B-type MCB. And with our newer machines, the R290 range, for example, we need an F-type RCD specifically for the single phase units. Three phase can still use the B-type. It varies from machine to machine. It's all to do with the inverter. So although the inverters can run on single phase, when they convert the energy from AC to DC and they pulse it back out in AC, it comes out in three phase essentially, and you can get residual feedback. So the type of MCB and RCD is very important. On that, as an example of something you should check on your servicing, a real world example is I had a heat pump installation. Someone went to service it, and during that period where they'd been to service, they'd had a new cooker installed, electric cooker, and someone had swapped the MCB for the cooker with the heat pump, and it caused issues. So you should always check your breakers and make sure that they're the correct ones. Yes.
Great, thank you for that. And then we've got a bit more on the servicing costs here. Patrick, I'm just reading your question, but if you wanted to unmute, I think you can now. There we go.
Hiya. Just following up on the servicing costs, because it seems quite large compared to what it would be for your typical sort of domestic boiler. I was just wondering, like you're giving the estimates of it in there, do you expect that will go down over time as more people are trained to do this and sort of a market mechanism thing going on, or is there like underlying costs that are keeping it higher than a typical boiler servicing?
So I would expect over time that they would go down once there's more availability and more competition from engineers who are trained on how to do it. So I would expect over time, once there's more people out there doing it, yes. I couldn't give you a time frame on that. When you look at if you look at a typical boiler install or a servicing, for example, typical boiler servicing is they come in, they check the expansion vessel, and then they would probably check that the system's up to pressure and maybe check the water quality on a sort of, it's a probably 15-20 minute check. When we're servicing a heat pump system, we're servicing the whole system. So we're not just looking at the heat pump outside, we're looking at the components inside, the water cylinders, the pumps, making sure that if inside the property, they'll have typically, zone valves, system controls and things like that. So that is all included in the service. It's not just a check that one component, you have to check the whole system, which is why the costs are a bit higher, typically for an air source or ground source heat pump.
Thanks for explaining that, Shaun. It's really informative.
Yeah, no worries. Thank you.
Yeah, thanks, Shaun. It's an interesting one. I think we've got some, local authority audiences as well who are working in, programs, social housing, low-income grants across large numbers of properties. So it's an interesting one to think of, that annual service over time and, programming that in. Yeah, not a question as such, but an interesting point
something to think about. Yeah.
Yeah. I don't think I have any more questions in the chat.
I actually come in for one more.
Sure.
Yeah,
Patrick.
sure.
That's okay. I'm just curious about what sort of servicing packages there tend to be. Like, will it tend to be that you get your heat pump installed and at that point in time you get the service package with the same installer? What's the sort of the market for it right now? Is it people reaching out to get their own servicing packages after an install?
Yeah, so I can tell you from my experience from working at Stiebel Eltron how we do it. So typically, what you will have is whoever installs the heat pump, the initial installer, they will offer the customer a service package, and they will carry out the annual service for them. Typically, when we do servicing ourselves as a manufacturer, typically what we get though is people who have been abandoned by their installer. Their installer's gone bust, or they're no longer available for them, and that's where we would step in. Our service package, for example, we include parts. So part failures, we include them, sort of free of charge. They're included within the cost. Obviously we include our engineers' time, things like that. So the packages vary, but generally it's taken care of by the installer, and we will generally take care of anyone who's sort of been left in the dark, really.
Thanks for explaining.
Right.
Thanks, Shaun. Okay, I think yes, I think we've come to end of Q&A. I don't think I see any final questions or hands up. So it was really useful. I think we learnt a lot. Very, very much on the importance of the service and how much it's linked to system performance. So I think it's a really strong key message to be taken away from this. Thanks for that, Shaun. Namitha, I didn't know. Oh, sorry.
No, yeah, carry on. Sorry, thank you.
Yeah, I didn't know if there were any further closing remarks, Namitha, or if we're happy to end it here.
Yeah, nothing further. Just want to thank everyone for attending. Thank you, Shaun. Thank you, Marissa, for coming in. And any further details will be shared with you over email. Yeah, thank you so much, everyone.
Great.
Thank you, everyone.
Thanks a lot.
Thank you.